Assalamu alaikum wa rahmatullahi wa barakatuhu. Hello, my children. How are you? Welcome back to another exciting lesson in our chemistry series on organic chemistry. So, today we are going to tackle some key concepts in organic chemistry using fun flashcards. So, grab your notebooks, get comfortable, and let's dive in. Hope you remember in chapter 4 where you learned about chemical formulae and equations, you learned something called molecular formula. And of course, I hope you are able to recall what's an empirical formula. So, to begin with, molecular formula, this is like a revision because you have already learned in detail about that in chapter 4. So a formula that actually shows the number of atoms of each element. So here you go, carbon has 4 atoms. Hydrogen has 8 and oxygen has 2. In which compound? In butanoic acid. So this is a molecular formula. Now, if you need to know the empirical formula, it actually gives you the simplest ratio of the atoms present. So how are you going to calculate the ratio? So take the smallest number. So what is the smallest number here? 2. So take 2 and divide 2 by everything, by all the numbers here. So what do you get? 4 divided by 2, you get 2. 8 divided by 2, you get 4. 2 divided by 2, you get 1. Of course, we do not write that 1. We never write 1 because that subscript, when you have an atom without anything in the subscript, it means it is 1. So that is understood. So this is what we had learned in, when we began the syllabus, what a molecular formula is and what an empirical formula is. So molecular formula, it shows the number, actual number of atoms in each element in the molecule. So if this is the butanoic acid, you have 4 carbons, 8 hydrogens, and 2 oxygen atoms present in it. Same way, if they ask you for an empirical formula, you just give the simplest ratio. A little bit of recap of what organic chemistry is. You know that it is a study of the structure, properties, and reactions of organic compounds. What are organic compounds? They contain carbon. So for conventional reasons, metal carbonates, carbon dioxide, and carbon monoxide, they are not included in organic compounds. Okay, so we will not deal with it. So many of the structures you will be drawing are hydrocarbons. So it is the simplest of the organic compounds that we have, and we will be drawing and studying hydrocarbons in detail. Hydrocarbon is a compound that contains only hydrogen and carbon atoms. So now let's get into what a displayed formula is. So displayed formula, what does it do? It shows the spatial arrangement of all the atoms and bonds in a molecule. So if you see a displayed formula, what does it is very important to know the displayed formula because it is clearly showing you the bonds. So if you look at it, it clearly shows the bonds. Can you see the bonds here? Okay, let me use the annotate because it's easier to edit later. So here you see, these are the bonds. So it clearly shows all these bonds. The displayed formula shows this. And if you see, it also shows you how many carbon atoms are there. So how many? 1, 2, 3, 4. So a butanoic acid has 4 carbon atoms. It has 8, 1, 2, 3, 4, 5, 6, 7, 8 hydrogen. It has 8 hydrogen atoms. And it has 2 oxygen atoms. So it is showing you in detail the number of atoms, and not only that, it also gives you the type of bonding that is there. So there is a double bond here. So this is how the displayed formula shows. Okay. So the next thing that we need to know of, a little further from displayed formula is called the structural formula. It's called the structural formula of the molecule. And this is also something important we need to know, because this type of formula is not as complex as drawing all the bonds. Can you see here? All the bonds are drawn. All the bonds are drawn here. But here, see, now the first carbon has 3 hydrogens. So we are not drawing all the bonds here. Instead, in a very unambiguous way, we are representing it together. CH3. Instead of drawing the bonds, it is presenting in this manner. The atoms of a molecule, the way they are arranged, it shows it this way. Okay. So if butanoic acid, this is a little complicated because it has a lot of bonds and all that, but then the structural formula makes it a little easy because we are concising it and putting it together. Okay, now coming to the condensed formula. Now you should know what condensed formula is, because here you don't see any bonds. Condensed formula does not give you any bonds. Instead, it's a shorthand way of writing organic compounds in a single line of text. So a condensed formula of a molecule is a formula where the symbols of atoms are listed in order as they appear in the molecule structure, with bond dashes and all that omitted. So if you see here, the table here shows structural formulae of some of the early members of different homologous series. Like alkanes, you have ethane, propane. So this is the molecular formula, and this is the structural formula. You will be asked to write the structural formula, so you need to know how to do it. You need to practice doing it. Alkenes, ethene, propene. So this is the molecular formula. Ethene has 2 carbons. Now, of course, the general formula comes in here, CnH2n. So try to substitute the number of carbons. And then ethene, it needs to have a double bond. So where is the double bond? So in the structural formula of ethene, you will see the double bond is here. Okay, now that's very obvious. Let's go to propene, where you have 3 carbon atoms. So where is the double bond? Double bond is between the first and the second carbon atom. We will see how to number the chain in a few, maybe in the next video, we will also see how to number the chain. So you will see that now alcohol, taking alcohol as an example, ethanol. So where is OH? In propanol, where is OH attached to? So structural formula also gives us where the double bonds are. Until now, we have considered only molecules made of straight chain. Like, we have not seen any branched molecules, the structures of branched molecules. So we have considered only molecules made up of unbranched, straight hydrocarbon chains. So like here, you have, this is a straight chain. This is a straight chain. Okay. Now, it is possible to have molecules where the chain is branched. Like, for example, if you take butane. Now, butane, 4 carbons. Now, instead of putting that 4th carbon here, what I am going to do is I'm going to make it as a branch. Okay, let me take this off and put this carbon here. So I have brought out a branch. Okay, so the 4 carbon atoms are not arranged in a straight chain. Yes, they can be, but they, they do not have to be always arranged, in a straight chain. So I've just brought that the 4th carbon can go off the main chain to be branched structure. Now here in this case, okay, we'll see the previous one, carbon, 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 and carbon. When it was a straight chain, okay, it was called butane. It's called butane. Now, if I drag this carbon and make it as a branch, the name will change to 2-methyl propane. We will see how that happens in a while. Okay, so here you see the molecule. Now, what is the molecular formula of this? What is the molecular formula of butane? C. Okay, count the number of hydrogens now. Here you have 3 hydrogens. Okay, there are 2 hydrogens here, 2 hydrogens here, and 3 here. So together, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So C4H10. So this is the molecular formula for butane. Now, when we talk about 2-methyl propane, 2-methyl propane, what is the molecular formula? Again, it would be C4H10. So, compounds which have the same molecular formula. So, compounds which have the same molecular formula but have different structural formula. Different structural formula are called isomers. Are called isomers. They are called structural isomers. So let's see a few examples. Let's see this example in detail. So here you go. So the molecular formula of butane is C4H10. Molecular formula of 2-methyl propane is C4H10. So what has happened here? The displayed formula, you have the 4 carbon atoms arranged as a straight chain and hydrogens filled in. So when you do that, how do you write the structural formula? So CH3, CH2, CH2, and CH3. So this would be our structural formula for butane. Now, when I drag, see, this is how we had carbon, 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 and I had 1 carbon brought down as a branch. So when I bring this, so let's see the displayed formula. So I have a hydrogen here, and another hydrogen here. So here there are 4 bonds, 1, 2, 3, and 4. And 1, 2, 3, and 4. So I have another carbon here. So I need to put the 4 bonds. So H, H, and H. So instead of writing it this way, this is my displayed formula. Now this is actually another functional group which is called the methyl group. It's called the methyl group. Okay, we learned about many functional groups. We learned about the alkane group, which has single bonds, alkenes, which have double bonds, we OH, or alcohols, and COH, carboxylic acids. So whenever, like if I have CH4, now what is CH4? CH4 is methane. If I drop one H from this and make it as CH3. So methane will become methyl. So this is another functional group which is called an alkyl group. This is called an alkyl group. So there are 2 factors that are important. Let me change my color to red, or let it maybe I'll make it white. So there are 2 factors that are important in naming the molecule of 2-methyl propane. The first one is, as I told you, this, the side chain that we see here, that is the CH3. I'm going to use another color here. So this CH3 group, okay, when we remove one hydrogen from an alkane chain, so this is an alkane, okay, methane, example methane. So when we remove one hydrogen group, when we remove one hydrogen from an alkane chain, we are left with a group known as alkyl group. So alkyl groups are named after the hydrocarbon by changing the ane, okay, alkane, ane to il. Remember, okay, YL. So alkane gets changed to alkyl. And when does this happen? When does this happen? When we remove one hydrogen. See, CH4 has now become CH3. So that's the first thing when you need to consider when you start naming a compound. So in this case, 2-methyl propane, how is the name there? How did you get that name? So the first thing is this, the side chain. So side chain is methyl. So alkyl groups are, okay. Now we call this methyl group. Let's say if you have, what is ethane, C2, so CnH2n plus 2. So the number of carbon atoms are 2. So 2 twos are 4, 4 plus 2, 6. So the molecular formula of ethane, this is ethane, okay? So the molecular formula of ethane is C2H6. And if I remove one hydrogen from this alkane and make it as C2H5, then I will call it as ethyl. This will be called as an ethyl group. And so on, propyl, pentyl, no, it will go on. So this will be our first consideration when we have to name a compound. The second consideration is the numbering of the carbon atoms. So we are done with this. We are done with the side chain, and we have named it as methyl group because it has 3 hydrogens, 1 carbon and 3 hydrogens. So now the simple, in this case, now in this 2-methyl propane, in this compound, it is simple as the methyl group is attached to the middle carbon in the chain of 3 carbon atoms. So there are only 3 carbon atoms. Let me push this up a little. Yeah. Or let me let me show you this structure, the displayed formula. Okay. So there are 3 carbon atoms here, and this side chain, that is the methyl group, is attached to the carbon which is in the middle. So it is kind of easier to name such compounds. So the second carbon, I think I need to change my color here so that it's easy for you. So let's start numbering the carbons. Carbon 1, carbon 2, carbon 3. Because you might be wondering from where this 2 came. You might be wondering, right? So if you number the carbons at 1, 2, and 3, so where is the methyl group attached to? It is attached to the second carbon. So we'll put that second there in the name. So in general, where a hydrocarbon side chain has replaced a hydrogen to produce a more complex molecule, we number the carbon atoms in the chain. And the numbering, remember, always starts at one end of the chain. So you start from one end of the chain. Okay? It can be this end or that end. The counting starts at the end, which keeps the number of the side chain position as low as possible. So here, maybe I will not be able to show you, but then if we have to take carbons more than 3, okay, I will show you an example where we have to take, how we number the molecule. I'll show you that in a few moments. So here you see the number where the side chain is attached to. It is attached to carbon 2. So 2. And what is the name of the side chain? It's methyl. And how many carbons are left here? There are 3 carbons. And what is the name of 3 carbons? It's prop. And do you find any other bond other than single bonds here? So it is ane. So 2-methyl propane. Now butane and 2-methyl propane are both alkanes and they have similar chemical properties. Remember what we learned about homologous series? Homologous series, the compounds in the same series, they have the same chemical properties. They will have the same chemical properties because their functional group is the same. They belong to alkanes. They belong to alkanes, so their functional group will remain the same. Because their functional group is the same, their chemical properties will also remain the same. So the difference between them shows itself mainly in their melting point and boiling point. So the difference between these two, they will have different physical properties. The physical properties can be different, mainly in their melting and boiling points. So hydrocarbons containing branch chains have lower melting points, lower boiling points than straight chain compounds with the same number of carbon atoms. So if you see, this example of butane and 2-methyl propane, they belong to the same homologous series, alkanes. So from this, what can we derive? We can derive that alkanes, that the homologous series, okay, homologous series, they have the same functional group. They have the same functional group. They have the same general formula. Remember, when we were trying to get the molecular formula, we use the general formula, CnH2n plus 2. So the same general formula. You have to kind of learn this. And the members that differ from one to the next by a CH2 unit. We discussed this in detail in the previous video. If you have missed that out, do watch it. And there is a consistent trend in physical properties with increasing molecular size. They will have similar chemical properties. They will have similar chemical properties. And I also spoke about isomers. So let's see what isomers are. As I told you here, see butane, it has the same molecular formula C4H10 and 2-methyl propane. Okay, let me take this off so that it is easy for you to see it. Okay. So the molecular formula of 2-methyl propane is also C4H10. So the same molecular formula, but look at the structures. Just look at the structures. So the structure is this way. It looks like it's a straight chain hydrocarbon, but here you have a branch chain hydrocarbon. So the structural formulae are different. So such compounds, they are called structural isomers. They are called structural isomers. So remember, structural isomers are compounds which have the same molecular formula but different structural formula, or the displayed formula, are different. So if you see, the structural formula is also different, the displayed formula is also different. Okay, let me move this up a little, because let's see another example for structural isomerism. See, it can be shown by members of any homologous series, any, not only alkane, it can be shown for alkenes, carboxylic acids, alcohols. It can be shown for any of the homologous series. Okay. For example, here, let's try writing butene. Okay, butene. Okay, butene has, it has 4 carbons. So 4 carbons. 1, 2, 3, 4. Now it is an ene. Okay, it's an ene. So let's put the double bond here. And I told you we need to number the carbons. So let's number them. 1, 2, 3, 4. You can also number it this way. Whichever way you number, you take the lowest value. If I have to number carbons like this, okay, I will, put the double bond here and I will take carbon 1. So remember, the lower value of the chain will be taken in. So now let's number it this way, and the first carbon, has the double bond. Okay. So now here, this is our butene. So 1, 2, 3, hydrogen, hydrogen. Okay. And so this is a double bond here. So 1, 2. I have to remove this because it's a double bond here. I don't want you all to get confused. So let me write this neatly. So here you go. So this is number 1. Okay, don't get confused. So 1, 2, 3, 4. So already the 4 bonds are done. The 4 bonds are done here. And here you go 1, 2, and 3, 4. So 1, 2, 3, 4. And here, okay. And then we have the other 3 bonds put here. Okay, so this is our butene. Now, let's be a little more specific. Okay, so here you go. Where is the double bond? Now, where is the double bond? Where is the functional group? In alkene. So it's on the first carbon. It's on the first carbon. So the name will change from butene to but1-ene. Fine? Hope it's not confusing. See the name, the organic compound, the names change, wherever the functional, you have to see the functional group. The first part of the name will show you the number of carbons, and the last part of the name will show you the functional group. So here the functional group, where is the functional group? It's at carbon 1. So this is but1-ene. Now let's tweak this a little. Okay, let's tweak this a little. Now what I'm going to do is, I'm going to change the color to red. All my carbons are going to be red. Okay, so carbon, 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 carbon. So my but has my 4 carbons. Instead of the first carbon, okay, let's number it. 1, 2, 3, 4. So instead of the first carbon, I have my double bond on my second carbon. Okay, so again, don't forget your hydrogens. Very, very important. Okay, so I have my hydrogen here, and 1, 2, 3, 4, and hydrogen. And remember the 4 hydrogens, do not forget them. Okay, so now again, this is but. My 4 carbons show that it's but. Now, where is my functional group? On which carbon is it? It's on 2. And it is an ene because it's a double bond. It's an ene. So this is another compound which is called but2-ene. So now what are these? If you write the molecular formula, what is the molecular formula? Molecular formula of butene is C4H8. But1-ene is C4H8. But2-ene also is C4H8. So if you see, the molecular formula is the same, C4H8. but the structural formula gets different. So these are isomers of each other. So but1-ene and but2-ene are structural isomers of each other. So structures are different, right? Again, the carbon atoms are numbered. The number added to the formula indicates the position of the double bond. So remember this number 1, number 2, it indicates the position of the double bond. In but1-ene, the double bond is between carbon 1 and 2, whereas in but2-ene, it is in between carbon 2 and 3. So these structural isomerism is this type of structural isomerism is known as position isomerism. It's called position isomerism. Position isomerism. Okay, so now hope that's clear. So do a little more practice. So let's try doing it for propanol. Try doing it for propanol. So all of you all pause your video here and try to do it for propanol. I want you to give me the two isomers of propanol. The two isomers of propanol. Now, pause the video here right now and try doing it on your own. So hope your structures were this. Okay, so these are isomers, propanol, isomers of each other. Propan 1 all and propan 2 all are isomers of each other. Okay, now the next thing that we are going to see are, the next tool, an amazing tool called the flashcards, through which you can learn, you can optimize your learning. Okay. So these are flashcards which I've kind of taken from, say, my exams, and they are a very good way of learning for your preparing for your exams. So let's begin. You have your books ready. Try to write your answers down. Pause the video and start writing your answers down. So define the term hydrocarbon. So hopefully you have written your answer as a hydrocarbon is a compound that contains only hydrogen and carbon atoms. Great. So let's go to the next question. Now, the molecular formula shows the actual number of atoms in a molecule. Is this true? Yes, this is true. This is true. The molecular formula shows the actual number of atoms in a molecule. So this was my question. This was actually my question. So this is the answer. Okay, things like this do happen. It's okay. So the third question, define the term homologous series. So remember, the points that I had given you, that they have a general formula, they have similar chemical properties. So try to include all the points that we discussed and then write your answer. So here you go. They are a family of organic compounds that have similar features. Chemical properties are similar, and they have the same functional group. You can also add on the same general formula here. So what's a general formula? So what's a general formula? A general formula shows a ratio of atoms in a family of compounds in terms of n, where n is a varying whole number. Like for example, if you have for alkanes CnH2n, which means that n is the number of carbons present and hydrogens are twice the number of carbons. So CnH2n. So this is a general formula for all alkenes. So likewise, we kind of did, general formulae. We learned the general formulae for other homologous series as well. Okay, so a functional group is a group of atoms bonded in a specific arrangement that influences the properties of a homologous series. Is it true or false? Yes, it is true. because functional group is indeed a group of atoms. Like, for example, alcohols, you will always see OH attached to it, attached to the hydrocarbon. For carboxylic acid, you will see COOH attached to it. For alkanes, it is a single bond. For alkenes, it's a double bond. So C double bond C. So C single bond C. So this is the functional group. And now we learned another one. What was that? The alkyl group. So what is the alkyl group? Alkyl group is where one hydrogen atom is less. Like methane becomes methyl group. So methane becomes methyl. Okay. Methane becomes methyl. So this is another functional group. And when the functional group changes, the chemical properties also change. Okay, so what's our next question? What define the term displayed formula? So what is displayed formula? It shows the spatial arrangement of all atoms and bonds in a molecule. So you will see the bonds as well as the number of atoms that are there in a formula. Okay, so here you have CH3, CH2, CH2OH is an example of a structural formula. Is this an example of a structural formula? So let's see. Yes, it is an example of structural formula as it gives enough information to make the structure clearly. Okay, so give two characteristics of a homologous series. So what is that? They have the same general formula, same functional group, similar chemical properties, a clear trend in their physical properties. Like, for example, the hydrocarbons which are smaller, the hydrocarbons which have a smaller chain will have lower boiling point. They will have a lower boiling point. So as they become bigger, the boiling point will increase. So you see the trend in their physical properties will be the same in the homologous series. So in all alkanes, you will see that, okay, sorry. So you will see that all alkanes, as the hydrocarbons become bigger and bigger, the boiling point also increases. So the difference in the molecular formula between one member to the next is the CH2. So we've kind of learned this enough. I have explained that enough. Now we will go to the next question. Okay, so what is the functional group of an alcohol? I'm sure all of you all are going to say it aloud that it is OH. Okay, so the R thing represents the whole molecule, the whole carbon and the other hydrogens in it. Okay, so alkene functional group is represented by CC single bond. Is this right? Of course not. Of course not. It is alkene functional group is represented by C double bond, CC double bond. Okay. So what are isomers? Isomers are compounds that have the same molecular formula but different displayed formulae, or you can also say different structural formula, different displayed formula, but they all have the same molecular formula. Okay, so here you have CH2, 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 CH3. It is is it in an isomer of this? Now here, isomers, they have to kind of, what you see here, this is a condensed formula. You see a condensed formula here. Now, how is this condensed? How is this condensed? You see the CH2, CH2, and CH2. You have three CH2s, so it is condensed CH2 thrice. Okay, so this is not an isomer. Instead, it is a condensed structural formula. Okay, let's go on to the next. So here you have CH3CHOH. This is an alcohol functional group. It is attached to the second carbon. Okay, so here you have CH3, CH2, CH2, and OH, which is attached to the first carbon. So it looks like both have the same molecular formula, but there is a change in where the alcohol functional group is attached to. So looks like an isomer. Let's see. Yes. So this is an isomer as the OH group has moved from the middle carbon atom to the end carbon atom. But the molecular formula is the same. Okay. So what does the prefix tell you in the name of a molecule? What does it say? It tells you the number of carbon atoms. Okay. How many carbon atoms are in a carbon chain if the prefix is prop? That's easy. It is 3 carbon atoms. The suffix, what does it mean? What does it tell you? It tells you the functional group, whether it is an alcohol, OH, alcohol, carboxylic acid, COH. Okay, it gives you the functional group. Okay, what is the name of this compound? Pause it, try to answer. So how many C's are there? 1, 2, 3, 4. So you have 4 C's, so it should be bute. There is an OH there, and it is attached to the first carbon. So bute 1 all. Yes. So the name, oh, what is the name of this compound? So 1, 2, 3, 4, 5. So 5 carbons, pent. It's pent. There are no double bonds. So it's pentane. My answers are coming first. I seriously don't understand why. What is the name of this compound? So you have a COH, the functional group, okay? And there are 3 carbons. So 3 is propanoic acid. Okay, so we have not seen this functional group, NH2, which is an amine group. So we will look into it in the next video. So bye-bye for now. Take care. Assalamu alaikum wa rahmatullahi wa barakatuh.